This is EHL Recap. Just a short rundown of the organization. We are a student-run organization. We post free content during midterms and finals for students by students. We give a short presentation and answer any of your questions at the end of the call. We post the content exclusively on our website at ehlrecap.tk. I put the link in the description. If you forget the link, don't worry. You can always log into our Instagram, ehl.recap. We have reminders on future recap sessions, and so make sure you are following that. We aren't affiliated with EHL, so make sure you don't keep us accountable if you fail. However, we have worked with other students who have taken this class before so that we know what material to put up.
Can I start?
Yeah, go ahead, Alex.
All right. Another disclaimer, I do not know what's going to be on the exam. I can only talk from experience and what I've seen the previous semesters. Hold on. Can everyone see the presentation on screen?
Yeah, we can see it.
Awesome. So the presentation in today's tutoring is mainly going to be about derivatives and applications of derivatives. Since I've seen it most of my friends in Bosco, and that there's a big confusion with this. And at least in the previous year and semesters, I've seen that derivatives, partial derivatives, optimization, constraints, or the use of derivatives is a pretty big part of the exam, or not necessarily a pretty big part, but the one that gives you the most to think. So I'll try to explain those in the easiest terms possible. For the rest of the chapters that will be covered in the exam, they're primarily formulas that have to be used and do not require such a wide application of the concepts, so I won't be covering them in this tutoring. All right, before starting, most of the presentation is going to be writing my own handwriting, so if you don't understand, just unmute yourself and ask directly. But those are some, I call them like rules that might help, or shortcuts. I think it's very good to know that 1 over x can be written, or 1 over x at any power can be written as x at the power of minus and the power that x is at. It's pretty useful when you have to derive something, because a lot of people might not know how to derive 1 over x squared, but you know how to derive. It's easier to derive when you see it as x at minus 2, because it's basically just minus 2 times x at minus 2 minus 1, so minus 3. And then I think it's also quite, not necessarily a must, but knowing that you can write square root of x in those two ways. They sometimes can pop up like this on the exam or on LMS. Just make sure you know them. It's going to be a plus. All right. This is a quick reminder of the derivative formulas and derivative rules. I strongly suggest you know them in the exam well enough so that you don't have to check your formula list every single time to see if you did well or not, because on the final exam, from what I've seen the previous semesters, you don't really have time to think a lot or check your notes a lot. It's more about how fast you can get to the right mode of thinking and solving the problem and start writing it. So I definitely suggest to work all the exercises that you have on your PPT from the professors with the derivation rules and everything, and know them by heart if possible would be great. Exercise will definitely take you there. Some econ terms as well that might pop up in the exam. I just remember that whatever economic terms that you see in maths, you don't have to know micro or any other subject to necessarily know how to write the profit or how you should solve certain phrasings. Because if you have, for example, the average cost, which is at the bottom, you know it's something divided by the count of that something. So in this case, the total cost over quantity. You don't need to know that then to write the total cost, you just have to multiply it by Q. You don't need micro for that or any other subject. But in any case, they do like to use a lot of economic terms. Those were the ones I could think about. If you found any other terms, either write to me and I can tell you how to solve it, or try to figure it out, or just write them down somewhere and know its formula if you think it's going to be difficult if they pop up. But those are the main ones that I've seen. So it's profit, the revenue function, it's widely known and it's never going to be different. It's price times quantity. And then usually the cost function or the total cost function is either given by the exercise directly or it's given in the form of the average cost. And then you'll have to deduce the total cost from that. So yeah, the cost basically it's given in any shape or form. And another thing that you have to keep in mind is when you see the word marginal, it means change, and most of the times it means the first order derivative. So in case you feel confused with an exercise or you don't know what to write, and you have the word change or marginal in there, maybe starting with the first order derivative might solve a bit of your confusion or save you for a point. Not sure though. All right. Now, about the partial derivatives, I've seen there's a bit of a confusion when deriving them and how to follow the order. So I gave a pretty easy example. The first order derivative in x, it means you just consider x as the variable that has to be derived. That means that y in that case becomes a normal number. So if it's alone, it's a constant. So if you derive it, it's going to be 0. And if it joins x, it's going to be a coefficient. So it will take its role as a coefficient within the derivation. So in case you have there 2xy, when you derive x, your result will be 2y. So very careful with that. I don't think that the first order derivative should be a problem. The letter that it says, that's the only one that has to be derived in each expression where you have x. Okay, here's the form for the first order derivative in x or in y. And then for the second order derivative, you have the second order derivative of xx is obviously you derive x again in the first order derivative of x. How do I? All right. Wait, sorry. So if you have fx and then the second letter is also x, then it means that you will have to derive x again in the first order derivative of x. So basically, when you do the second order derivative, it just the first letter down, so in this case x, tells you in which first order derivative function you should derive the respective variable, which is the second one. So let's say if you have f of xy, in this case it means that you derive y in the first order derivative of x. So you will derive y in this expression, but not both of them. And the other way around as well. So fy of x, it means that in the first order derivative of fy, you will derive x. So in this case, the result's going to be 0. Just very quickly, if you want to check yourselves that you did the partial derivative correctly, fxy and fyx is always equal. Always, 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 always. So if those two are equal, there's a very good chance that your derivatives are right and that you did the exercise correctly. If they're not equal, try to check where you did a mistake. This is the same explanation as I did above, but if you get to the presentation, it just basically explains how to read so you understand to do the derivatives. It's literally just what I said. The first letter shows you in which first order derivative x, y, or fy you should derive the second letter. So that's basically like the cheat code for knowing which variable to derive. And considering a different example, I don't know if you have this one in your presentation, but I know it was in my maths slides when I was in Boston. Okay. About the total differential, there is no other formula to use but this one. You see, it can be as continuous as infinity in this case, but normally you, at least in EHL, you won't have more than 2 or 3 variables, so xy or xyz, let's say. But it's pretty simple. When they ask you what's the change of the function, you first do the first order derivative, and you also find out the change, and then you just multiply them and add those for each variable. So when you have a problem in the exam, for example, and they tell you that
there is an increase of 880, that means that we need to subtract this from the net income.
Good. Okay. Where was I? Yeah. So if an exercise tells you that your x changes by 2 units, and that your y stays the same, it means that the change is y, it's gonna be 0. So you automatically can disregard this, and your change in x, it's 2. So you just do the first order derivative of fx, multiply those, and then you get the change of the whole function. And that's what the total differential it is about. It's not very complicated. Just see where you have the changes and then apply it directly in the formula and do the first order derivative. Oh, all right. So moving on to the unconstrained optimization. Is everything clear so far, or does anyone have questions? Because I can't see the chat. Can I get a thumbs up if everything's okay, if I can move on?
Yes, all good.
Okay. So about the unconstrained optimization. For the first order derivative, it's pretty easy. The golden rule that you have to know is you always equal the first order derivative to x. Whether you get an equation or not, you always do the first order derivative equal to x. That's your first step and your golden rule. You cannot start without doing this. So if you see the word optimization, maximization, minimization, whatever, first order derivative equals to 0. I think before I said x. No. First order derivative equal to 0. There you go. And solve the equation. Then you compute the second order derivative, and depending on the sign of your second order derivative, you can say whether your critical point is a minimum point or a maximum point. The reason why you compute the first order derivative is because it's part of the rule for you to be able to phrase the demonstration that a point, it's a minimum or a maximum. And usually it may ask you what type of point is x equals to 2, for example. So in that case, you will solve everything, do the second order derivative, replace x with 2, or if the second order derivative doesn't need to have a 2 and is already a constant, you look at its sign, and if it's bigger than 0, then it's a minimum point. If it's smaller than 0, then it's a maximum point. But always, 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 first order derivative equals to 0. That's your start point, and if you're lucky enough to have partial points in your exercises and be asked, like, find this, like, take it step by step, I think this is a pretty easy point that you can get. Do the first order derivative correctly and then solve the equation equal to 0, and it's all going to be fine. The unconstrained optimization for the second order derivative. I had to write them by hand because it's very hard by computer to do so. But I'll go step by step with the pictures. So I used an example along with everything. So if you guys want to write already the formula for yourselves, then we can go step by step, or just follow me. Do as you think. I took this from my math slides when I was in Bosque 1. You have it in your slides as well. But yeah, I'll try to explain it as concrete and easy as possible. So I separated it in 5 steps that I believe are pretty explanatory of the entire process, and that if you follow them literally word by word, you shouldn't miss any part of the process. The first step, just like before, compute the first order derivative. But in this case, you compute also in x and also in y, and you equal both of them to 0. So just as the unconstrained optimization for the first order derivative, in the second order derivative, you still equal the first order derivative to 0. Can't stress how important this is. You cannot start an optimization exercise without doing the first order derivative equal to 0. Then, in the case of a second order, yes, you will have a system. You had systems also for the midterms, so that shouldn't be a problem in solving it. And you will find out x right from the first step. And you may get 4 points, 2 points, 1 point, doesn't matter. Because it depends on the order of your equation. It's a first order equation or second, quadratic or not, doesn't matter. The amount of points that you have. The idea is you will find x and you will find y. And you receive 2 points from here, and then 2 points here. In total, you have 4 points. Those are your critical points, basically. Because when you do your first order derivative, you find out your critical points. But you cannot call if they are a maximum or a minimum, or if the function changes its direction at them. Because this can only be proved by the second order derivative. So although with the first step you find the points that you further have to decide their nature, you will not use them until the end. So you just let them sit there. You've determined them very good. At least you know you're on the right path, or that you got some points. Then the second step is simply compute the second order derivative and make sure that your fxy and fyx are the same. Otherwise, you're wrong. So check your derivatives again. Then the third step is you have to compute the Hessian matrix. Now, I know that your semester does not have matrix as part of the curricula, but pretty much what you have to know is just the placement within the matrix. Now, I've tried to kind of color code the letters, but I don't think it should be any difficulty in just placing it. I don't know how through LMS they can make you write the Hessian matrix, but you probably won't be able to solve it, to solve such an exercise without it, unless you just know directly the the formula of the determinant. So if you're not asked the form of the Hessian matrix, you can directly compute this and forget about the third step. Because normally the third step, it's required visibly on paper. But whether you write it in this form or not, you still have to compute the determinant of the Hessian matrix, your epsilon. Most of the time it's going to be called epsilon. Once you compute this determinant, and this formula never changes. So that's why I'm saying you don't need to know the matrix or stress over the fact that you have a matrix. Just know that formula and compute just put in the second order derivatives and solve it. Now you can get an equation from it, or you can get directly a number. Well, it's not necessarily a problem whether it's a constant or it has this form where you still have the x and the y within it. Because in the end, you will only care about the sign of your determinant. So if your determinant will directly say 6 or 2 or 3, you know that your determinant is bigger than 0 for whatever point. And so once you computed the determinant, you can start defining the nature of your critical points. So actually giving more information about the points that you found in step 1. And then you just consider it by cases. So you take every point that you found, so every pair of x and y, and you choose 99% of the time the second order derivative in x, so the fxx. If you use that one, it's going to be correct 99% of the times. And I have not yet had a case in EHL where we did not have to use that one. So I strongly suggest that the moment you arrive at the last step where you have to define the nature of your critical points, the first thing you have to know is you're going to consider fxx as the function where you will be replacing with the points that you found, and that you have to know epsilon. Just a second. If anything's not clear, please write in the chat until I drink some water. Did I move too fast, or did you manage to follow and understand a bit the steps of the unconstrained optimization? Give a thumbs up. Anyone? Okay.
Good.
So, continuing, what you could be asked is, for instance, they just give you like, what type of point is, let's say, this one here, when your x is -1 and your y is 0. For this, once you compute the values of your epsilon, so of the determinant, and the second order derivative in x, you just need to check the signs of both of them, and those rules will give you the nature of the point. Now I've wrote all of them that can be possible. There's only one missing in the case here, which is when epsilon equals 0, and that means that you have no information about the point. It doesn't mean it doesn't exist. It just, you don't know what happens in that point. So just say no information, or we don't know. But you do need to know the case for what happens when you have the epsilon smaller than 0. It's always a saddle point. And then if your determinant or epsilon is bigger than 0, in that case, you have a maximum point or a minimum point. Now, not all the functions that you will get will give you 4 cases of points. Some of them may only have just 2 of them. And in the case of that only 2 points, you can have, in both cases, let's say, the determinant bigger than 0. So depending on the second order derivative sign, you'll know if it's a maximum or a minimum. Now, this is the last part of the tutoring. I'm not going to go over the Lagrange theory, just because you just replace with lambda in a one equation. So it's basically, instead of using a partial derivative, you're trying to, instead of using a linear or a first order derivative function, you're going to turn it automatically in a partial derivative function. Now it's up to you if you want to solve it like that or not. In some cases, Lagrange is definitely necessary, but if you can solve with substitution, do try so. But although it's probably the easiest method, for some reasons, it can sometimes seem confusing. So when you have constrained optimization, most of the time, the problem will tell you that you want to minimize or you want to maximize the profit. Well, usually you want to maximize the profit. So in that case, you need to remember that the profit is revenue minus the cost. The cost function you might be given, or you will be given because you have to. But the revenue function, it's always price times quantity. So you already know how to deduce your own profit. So if it says that you have to maximize the profit, the function that has to be optimized is your profit. So in that case, it would be P of X, let's say, pi, the sign. If it can also say that you want to minimize the cost. In that case, they're going to give you the function of the cost. And that's implicitly the function that you have to optimize. So your main function, the one that you're going to derive, the one that you're going to use to find out your final results. But there's always going to be a constraint. And it's usually it's either budget or that you can have a limit of your quantity, or that your bank put some interest in. The idea is that you will receive like an extra equation to it, which is normally your constraint. Don't know if I did an example or not. No, I didn't. So what you want to do is first, obviously, identify your optimization function and your constraint. But as I said, usually the function, profit or cost or revenue or whatever, that is the closest to the word minimize or maximize, it's usually your optimization function. When you're given the function of the constraint, or you deduce the constraint that you have, either your budget or the limitation on your quantity, you will use it as a method to turn your optimization function in a one variable dependent equation. So if, for example, if your constraint says x plus y equals 100, you just want to write one of the two in function of the other. So in this case, we took y equals 100 minus x. You always want to take out one of the letters so that you can then just replace it within the optimization function. And from there, it becomes pretty simple. You do the first order derivative equaling to 0. You compute the second order derivative. And depending on the sign of your second order derivative, you know if your function is maximized or minimized. If the problem says you have to maximize your profit, the second order derivative of your profit is indeed larger than 0, then you should have the options to say correct or true, or the function is maximized. If the problem says that your profit has to be maximized, but your second order derivative is actually smaller than 0, then it's a false statement. And this is pretty much a step-by-step view of the derivatives and of the applications that you can have with the derivatives. I hope it's less confusing, or that it doesn't look as complicated as it may seem. And if you have any questions about the presentation or about the theory or about a rule, either unmute yourself or write it in the chat. Otherwise, I'll go back to study for my finals as well. Thank you.
Yeah, hi. I have a question. Do you know what are the cases where we can only use the Lagrange method?
Usually the Lagrange method you will be using when you see that you have a function that depends on, let's say, two types of quantities. So if you would be given to minimize the cost that depends on a company that sells two products, so you have Q1 and Q2, in that case, you will be using Lagrange.
Okay, thank you. And just, I couldn't remember. I think in the first slide, I just had I was a bit confused because I saw that you wrote that the second derivative was equal to 0, and the first derivative, here was, okay, no, I get it, because...
No, it's when you do the second derivative.
Okay, but you take the second from the first derivative of x, and then you derive it for y. So then
it should be 2 there.
Yes.
It should be 2, but I took them from the slides.
Okay.
So when I send Rachel the presentation, I'll it's gonna be corrected.
Okay, thank you. I was just a bit confused. Thank
I'm sorry for that.
No worries.
I think you guys have the same mistake in the slides as I did in my BOSC 1. Apparently, they never corrected it. Any other questions?
Yes, I have one question. I'm putting it in the group chat right now.
Yeah, and hi Alex. I was wondering if you will share the slide on the EHL Recap website.
Yeah, they're gonna be on the website.
Okay, cool. Thanks.
Alex, did you catch that? Maxine, do you have a question?
No, it was just from before. So.
Okay. Thank you. Good luck. So if you don't have any more questions, we're going to finish it here. For those who have questions, I know that someone's writing one in the chat or waiting. I don't know. Okay. For this case, when you have to find the consumer surplus, you will have to do the graph. So what I suggest you do is you write the function in the easiest form possible. So if you don't want to use it as your radical to have the square root and everything, perhaps an easier version to write it would be 10 times q at the power of 0.5. And then you use the classic way of computing a graph.
Okay, thank you.
No problem. Any other questions?
Thank you for taking the time out of your day to do this. It's very much appreciated.
No problem.
Yeah, thank you, Alex. Good luck.
Good luck on your exams, guys.
Thank you. Good luck to you too.
If you have additional questions and you can't figure them out please contact me via email. Who has been at the last tutoring session has my email, or try to find it, because last time I received a lot of emails. And although I managed to respond to all of them, I don't think that now I can. So unless it's something that's really burning or that stresses you out and you don't understand, try to figure it out. Otherwise, just send me an email and I'll try to answer as fast as possible. Thank you.
Thank you, Alex.
Bye.
Bye.